Section 5.4, Dividing Polynomials. In this section, you're going to learn how to use long division to divide polynomials. You're going to learn how to use synthetic division to divide polynomials. Here is a warm-up activity from the previous section. Find a polynomial function with the given information and sketch a graph of the polynomial function. The intercept is 0 and -9. That is, of course, the y-intercept because the y value is there and the x value is 0. The degree of the polynomial is equal to 5, and then x equals 3 is one of the zeros with multiplicity of 2. X equals 1 is another 0 with a multiplicity of 2. X equals -1 with a multiplicity of 1. And this is the behavior of the function. On the left side of x, the graph goes up. On the right side of x, the graph goes down. So let's begin by finding the polynomial. I'm going to start with the zeros and their multiplicities. So when x equals to 3, I will get the factor x minus 3, and the multiplicity is 2, so I'm going to raise it to the second power. And I will put an a here. Here is an f of x, which is the polynomial basically, times the second 0, which is x equals 1, will give me x minus 1. The multiplicity is 2, so I'm going to raise it to the second power. And then the last 0 is x equals -1, which will give me x plus 1, and the multiplicity is 1, so I will leave it like that. I will find the a value, so I'm going to use the y-intercept. So I'm going to plug -9 equals to a times -3 all squared. 0 minus -3 is -3 squared. 0 minus 1 is -1 all squared, and then 0 plus 1 is 1. So that will give me -9 equals 2. 9 times 1 is 9, so 9a. Let me put the a like that. And then divide both sides by 9. You will get a equals to 1. So the function is going to look like this. F of x equals to x minus 3 all squared, x minus 1 all squared, and then x plus 1. Now, the graph of this function, I'm going to sketch a small one here. It's going to look something like that. So I'm going to first plot the x values, or the x-intercepts, or the zeros. So I have -1 here, and the multiplicity here is 1, so the graph is going to cut through. And then I have at 3 and at 1. So at 1. And the graph here has a multiplicity of 2, so it's going to touch and bounce. I will see if it will touch from the bottom or from the top. And then there is another one at 3. So this is 1 and this is 3, and the multiplicity is 2 for both of these. The end behavior on the left side, the graph goes up. So the graph goes up here. And then I have a y-intercept at 0 and -9, which is approximately there. So the graph is going to go here. It's not perfect. I'm going to try to make it a smooth curve. Cuts at the y-intercept, and then it touches and bounces here. It touches and bounces there, and it goes down. Because on the left side of x, the graph goes down. So that is basically a sketch of the function. Without using a calculator, find the quotient and the remainder of the following. 298 divided by 21. So this is basically long division. So we're going to say 289 divided by 21. First, I'm going to divide 28 by 21. The answer is 1. So how many times does 21 go in 28? 1 time. 1 times 21 is 21, and then I'm going to subtract to find the remainder. So the remainder here is 7. 7 divided by 21. 21 doesn't go into 7, so I'm going to drop down the 9. 79 divided by 21 is 3. 3 times 21 is 63. And then I'm going to subtract. The answer is 16. I cannot divide any further, so I'm going to stop here. So I'm going to write the quotient, which is this number. That is the quotient, which is basically the answer. We call this number here the divisor. And then we call this number a dividend. And then this number right here is the remainder. So we can say basically, we can rewrite this expression as 13, which is the quotient, and then plus the remainder over the divisor. So we can basically write it like that. Division and factors. When we divide one polynomial by another, we obtain a quotient and a remainder. What does this mean when the remainder is 0? What does it mean when the remainder is 0? So when the remainder is 0, it means that the divisor is a factor and the quotient is a factor. So the divisor is a factor of the polynomial and the quotient is a factor of the polynomial as well. So that is basically what that means. The division algorithm. The division algorithm states that given a polynomial, f of x, and a non-zero polynomial divisor, d of x, where the degree of the divisor is less than or equal to the degree of f of x, which is the dividend, there exists a unique polynomial, q of x, the quotient, and r of x, the remainder, such that f of x can be written as d of x times q of x plus r of x, which is basically the divisor times the quotient plus the remainder. Q of x is the quotient, r of x is the remainder. The remainder is either equal to 0 or has a degree strictly less than the divisor, d of x. If the remainder is 0, this is the meaning. Then d of x divides evenly into f of x. This means that both the divisor, d of x, and the quotient, q of x, are factors of f of x, which is the original polynomial. Example, we're going to use long division to solve this problem, and then I will show you how to do it using synthetic division. It's just the same thing, okay? So here I'm going to write it as, I need to divide 5x squared plus 3x minus 2. We need to divide it by x plus 1. So here is how this is going to go. The first step, we're going to divide. So we divide the first term by the first term. We divide 5x squared divided by x. The answer is 5x. So I'm going to write 5x here in the quotient area. And then I will multiply the quotient by the divisor. So I will multiply. So 2 multiply the quotient by the divisor, d of x. In this case, it's going to go like this. So I'm going to multiply 5x times x is equal to 5x squared. 5x times positive 1 is positive 5x. Now we're going to subtract. So to subtract, we're going to subtract here, which makes me change the sign of both of the terms. The first terms are going to cancel. 3x minus 5x equals negative 2x. And then I'm going to bring the negative 2 down as well, and then divide again. So I'm going to go back and divide. So the third step here that we did is subtract. And then 4, we're going to bring down the remaining term, and then we're going to repeat the steps one more time. So we're going to divide the first term by the first term. We get negative 2x divided by x is equal to negative 2. So we're going to say negative 2 here. And then we're going to multiply the quotient that we added here by the divisor. So negative 2 times x is negative 2x. Negative 2 times positive 1 is negative 2. Now we're going to subtract, which means I have to change the signs here. Notice how negative 2x plus 2x cancels. It's 0. And then plus negative 2 plus 2 is 0. So the remainder here is equal to 0. And we can write the function, or we can specify that the quotient q of x is equal to 5x minus 2, which is basically this value right here. Let me actually change the color. So that is the quotient, and then the remainder is 0. So r of x is equal to 0. Now we can basically write the function. So if this is the function, then 5x squared plus 3x minus 2 is equal to the quotient, the divisor, times the quotient, so x plus 1 times the quotient, 5x minus 2. And we do not have any remainder here, plus 0, which makes this a fully factored, in this case, polynomial. but it's also, if you notice, it's also a quadratic, and we could have factored that using the AC method. Here is another example. We're going to use long division again. So I have 6x cubed plus 11x squared minus 31x plus 15. We need to divide that by 3x minus 2. So I'm going to divide first term by first term. 6x cubed 3x is 2x squared. Now we're going to multiply this by 3x, so 2x squared by times 3x equals 6x cubed. And then 2x squared times negative 2 is negative 4x squared. Now we subtract, which means we change the signs. Now we get these cancels, 11x squared. Sorry, this sign is positive actually. So we have now here 11x squared plus 4x squared is 15x squared. And then we bring down the remaining terms, so 31x plus 15. Now we divide one more time. 15x squared divided by 3x is equal to 5x. It's equal to 5x. And then we multiply. 5x times 3x is equal to 15x squared. 5x times negative 2 is negative 10x. And then we subtract, which means we're going to change the sign. These cancel. Negative 31 plus 10x is negative 21x. And then we bring the 15 down. And then we keep dividing one more time. Negative 21x divided by 3x gives me negative 7. Negative 7 times 3x is negative 21x. Negative 7 times negative 2 is negative 14, positive 14. Now we're going to subtract, so we're going to change the sign here, change the sign here. These will cancel, and we have 14 plus 15 is equal to, this is negative. So this changes into negative. So now we have 15 minus 14 is positive 1, and that should be the remainder. So now we have that quotient q of x is equal to 2x squared plus 5x minus 7, and the remainder out of x is equal to 1, basically. So that is how we're going to use long division in order to divide polynomials and factor some of these polynomials fully.